Good afternoon, everyone. Okay, today it is the 9th day of workshop. Okay, we are going to learn about neural network and deep learning today. Okay. So today is 9th day. Today we are going to learn about neural networks. So what is a neural network? So as we know neurons, right? So that is the biological neuron is responsible for all the decisions, all the thinking process. For everything, we are using this biological neuron. In the same way, based on that, the artificial neurons were created, and with that, we are processing the data. Okay, so neural network means it's a data processing system which consists of the large number of simple and interconnected processing elements known as artificial neurons. So we know this is the biological neuron. So here when we see, we are having dendrite, synapse, cell body, axon, nucleus. So the components are replaced in the artificial neurons with input, weights, the activation function, and the output. Okay, so in the processing will happen in the nucleus. So in that way, it is reformed. So from the structure of biological neuron, we are forming the artificial neuron. So how it is happening? When the system, that is biological, the artificial neuron receives the input, that will be multiplied with the weights, the corresponding weights, and the bias will be added. This weights with the input will be summed up, and the bias will be added. That will be sent to the nest neuron. So the nest neuron will process this as the input. Again, the nest neuron will send this information further till it reaches the corresponding output. Okay, this is how the processing is happening. So in automatically we can tell in a ANN, that is artificial neural network, we are having an input layer, hidden layer, output layer, the weights between these layers, and an activation function in this hidden layers. So what is input layer? In input layer, we'll be giving the inputs. Okay, then hidden layer means we'll be having in between the input layer and hidden layer, we'll be having this, output layer will be having this hidden layers. Next, we'll be having the weight in each layer, okay, for giving the importance, or if a particular input is needed, some importance, we can alter this weights. So according to our need, or for the output, we can manipulate, we can change the input, the corresponding weights, and also the bias. So here you can see a small problem. Okay, consider this as the input and this is the output. Okay, so here we are keeping the weights as 1 and the inputs are 0, 0. Then the output should be 0. If I'm giving the training data as 1, 1, it should give 1. If I'm giving training data as 1, 0, it should give 1. Again, if the training data is 0, 1 with the weight of 1, it should give the output as 0. Okay, so this is the training data we are giving. So what is training and what is testing? Here we should know about these two terms. That is training and testing. Training means we are making the system to learn about certain things. That is what training. So whatever may be the output we needed, according to that particular output, we are making the system to learn. So what we are making this system to learn, if the input is 0, 0, you should give the output as 0. So automatically, if the input is 0.1 and 0, the system should give me the output as 0. Hope you understand. So in this way, we have to train that particular system. So testing means we have to give a new situation like 1, 0, 0, and we have to find the corresponding output. So how to create a neural network class? So in the group, that is in Telegram group, I have shared a code. You can go through that particular code. Okay, so there I'm importing the library, that is NumPy, and there I'm using 4 important methods known as ESP array dot random. So we can take that particular code. All of you can take the code. So I have shared it. So I hope it is visible for you. So here what I'm doing, here I'm creating a small neuron. Okay, so with W0X0. So with that, I'm creating a small neuron. So the class neural network is created. Okay, and I'm initializing it. So in the initialization stage, I'm creating a random number. Then I'm creating the weight, small weight I'm creating, and I'm defining a sigmoid function. And for that sigmoid derivative I'm creating. Then with this initialized function, I'm training the system. So what is training? So I'm making with the corresponding input, I'm making the system to learn about that particular input and output. Okay, so here then with that I'm making the error. With that error, I'm making the adjustments. Okay, so that is what training means. What is training? With the input and output available, I'm making the system to understand what it is. With that, I'm finding the error. This is the particular function finds the error. With that error, it adjusts that particular system. Okay, so with that adjustment, the weight is changed. So this is what training means. So this thing is nothing but the testing field. So here we are getting the inputs and correspondingly we are finding the output and we are returning the output. So I hope you understand. Here we are giving the defining the sigmoid function. We are creating a random number we are generating. With that, we are creating the weight. Next, we are defining a sigmoid function. We are defining the sigmoid derivative. Then we are training the system with the given input and output. With that, we are creating the error. We are identifying the error. With that, we are adjusting. We are finding the adjustment. With that adjustment, we are making the adjustment in the weight. Okay. So if it is, so how it is, now we are going to do this. We are going to create this. So here the inputs given are, this is the array, np.array. This is the array 001, 111, 101, 0001, 1. So what it is? Here, 00 are the input. Sorry, 001 are the input, isn't it? So 001 in the first input. So for that, what is the output? 0 is the output here. Then 111 is the input. For that, output is 1. 101, output is 1. 011, output is 0. So these are all the training inputs, and this is the output. Okay. So with that, I'm calling the function train. So when I call this function with the iteration 15,000, where it will go? It will go to this function. So here it will train itself, or it will learn itself. And here I can take the inputs. Okay, here I can take the inputs. 3 inputs I'm taking. With that, I'm calling the function. Okay, with that, I'm calling the neural network dot think function where the testing is done. Okay, shall we execute it? So when I'm executing, it is asking for values. Okay, so I'm giving 1.0. Next is 1. Again, 1 I'm giving. So it gives the output like 0.99. 0.99. It's approximately 1. So how it is coming? 1, 1, 1. For that, the output is 1. So we are getting the output. So I hope, so this is how we have to create the neural network. So see this. So I was explaining this now. So in this way, we have to create the neural network class. So this is the next, I taught about the training the model. So through the input and by computing the error, and we have to adjust the weight. With that, we have to train the network. So this is neural network. If it is the neural network, what is deep learning? So deep learning means, so it is, as we all know, it is the subset of machine learning, isn't it? From artificial intelligence, the subset is machine learning, then deep learning. So this deep learning it is nothing but where we'll be having neural network. So when the hidden layer is more, when the learning is so deep, we will tell that particular learning scheme as a deep learning scheme. Okay, so here it's nothing but a class of ML algorithm. Here multiple layers of nonlinear processing units will be there for extracting the feature and for transforming it. So it can be when used for supervised or unsupervised learning. Okay, so see this, ma. Here the one input layer and one output layer is there. We are having here 3 hidden layers. So it's a small example of deep neural network. So as I said earlier, here also we'll be having bias. Here also we'll be having the weights. So according to our output we need, we will change this and we will do the work. So how to train a deep architecture? Here we will be having multiple layers of neurons. So we will train each layer. Okay, here we will train each layer from the smaller component to the higher level. That is, first, if it is an image, first we will process the pixel. Okay, for pixel, we will create each neuron. Then the edges, then the contours, then the object part, then the categories, then we will find the local feature, then we will find the global features. In that way, we will train this deep architecture. So this is an example for small perceptron. So that that we have implemented. So what it is? These are the inputs x1, x2, xm are the input. So with that, we are getting the output as W0, that is weight, plus summation of j equal to 1 to m xj wj. Okay, so this is a perceptron. This is the multi-layer perceptron. Here we are adding one more layer. Okay, so here comes the concept known as dense layer. So what is a dense layer? Here, when all inputs are densely connected to all the outputs, they combine together to form a layer known as dense layer. So when implementing it, so the dense layer can be implemented like this. So I hope you can see this code. So the for this we'll be using TensorFlow. We'll be using the packages TensorFlow Keras, inside that layers. From that we'll use the layer. Okay, this packages will be using. So they will be giving the input and output. Okay, so here we'll be adding the weights for the input dimension and the output dimension. With that, okay, with the corresponding input and the output, it will form a dense layer with the by multiplying the inputs with the weights, by adding the corresponding bias and passing it through the sigmoid function, we will get the output for that particular dense layer. So what we can do, only by calling this particular class, we can create a dense layer automatically. You can see here. Okay, how we are doing? We are just calling dense layer with the specific unit. So this will call this particular class. So automatically it will create a specific dense layer. Okay, so this is how the dense layer we are calling. So next we can see about convolutional neural network. So the convolutional neural network, shortly sir will explain about the practical part of that. I'll give a small the concepts about the CNN. So as you all know, normally we will use the CNN for most of the computer vision applications. So here what it is, it will be having CNN means it is nothing but a deep neural network. This will have a specific layer structure. Okay, a convolutional neural network means it will have a specific structure. We know we'll be having an input layer and an output layer, isn't it? So in between, we'll be having convolution layer. Along with that, we will have an activation layer, that is ReLU or any other activation function. Then we'll be having a pooling layer. Okay, so these things are mandatory. Okay, so then we'll be having a fully connected layer, and according to our need, we may or may not have a classification layer. So some hidden layers and some classification layer forms the CNN. So if it is, first we can see what is a convolution layer. So convolution layer, it transforms the input image for extracting a specific feature from it. Okay, some specific features we can get through this convolution layer. So through what? We'll be using a kernel or a filter. This filter will be kept over all these pixels. You can see the calculation. AX plus BX, sorry, AW plus BX plus EY plus FZ. So this will be replaced in with for this 4 pixels. So instead of this 4 pixels, we'll be getting 1 pixel by formulating this calculation. So we'll be getting more prominent information or more prominent feature from this convolution layer. That is, through by using a kernel or by using a filter, we are convolving that feature. That is what that is what happening in convolution layer. Next is pooling layer. So what is pooling layer? Pooling layer we can use different mechanism for pooling. Okay, so we may use max pooling or average pooling. So here it shows the max pooling. Max pooling means here we will be getting some information, isn't it? From that, okay, from that we can take the most prominent feature. So what is most prominent feature? So by when we apply the max pooling, this 2 cross 2 they are taking. So with that, which is the maximum number? 1156. Among that, the maximum number is 6, isn't it? So we are replacing this 4 bits with 6. That is one value. So we are doing max pooling here. Okay, so max pooling is done in this particular place. So that is known as max pooling layer. So the convolution layer along with pooling layer we are doing. Next is fully connected layer. So fully connected layer, it represents the, it maps the representation between the input and the output. So fully connected layer, what it will do the mapping between all the input to the corresponding output. So according to the output we needed, this fully connected layer will map the input. Next is about activation functions. So will be using many functions like sigmoid, ReLU, tanh. Likewise, many functions will be using. So according to the applications or according to the inputs we'll be using this activation functions. So this functions will make the input between a certain range, that is 0 to 1 or within 0 or -1 to 1. That is what happening in activation function. So CNN as symbol structure will be like, with the convolution layer, a ReLU will be formed. Along with that, this input will be given to the, this output will be given to as the input for the pooling layer. Again, from that pooling layer, another one convolution plus ReLU will be there, which will be given to another pooling layer, which is given to the fully connected layer, which will be given to the result, or if it is a classification algorithm, we'll be using softmax kind of classification layer. So thus we'll be getting the result. This is a simple function. So now what is a loss function? In the normal neural network, we have adjusted the weight. Hope you remember. So likewise, here also we have to find the loss. So between the two output, that is the expected output, we have to find the difference with the predicted output. With that, we have to find the loss function. So which will be used for adjusting the weights and adjusting the functions which is happening in the hidden layers. Next is about optimization. So optimization algorithms are responsible for reducing this losses. This losses will be reduced by adjusting this optimization function. So this will initialize the weights, and it will do the change the epochs which we are doing. So all these things will be adjusted with this optimization function to get the proper output. So a lot of algorithms will be using for optimization functions also. So I have given a brief idea about what is a neural network and what is a deep neural network. So the remaining part will be handled by Krandi sir. Okay, so I'll give us, I'm giving a revision on it. See, what is a neural network? So it is nothing but a collection of collection of processing elements in an architecture for doing a specific task. Okay, so and it is inspired by the biological neuron. Here the components of a biological neuron are replaced with the components of artificial neurons. Okay, so what all the things will be there? Input layer will be there, weights will be there. They will be combined and they will be processed with a particular function to get a specific output. So next is about the components of ANN. We are having input layer, hidden layer, output layer, weights, and activation function. So in input layer, we will get the inputs. In output layer, we will get the output. The functions will be happening in the hidden layers. The weights between the layers will be used for giving the proper weightage for this inputs and the hidden layer intermediate outputs. So this example we saw for training this particular data and to get the testing result in the corresponding situation. So how to create a neural network class and to train the model. So next we learned about the deep learning. So what is deep learning? So when we add many intermediate layers in the normal neural network, we will say it is deep learning. Why the term deep learning? Since the learning is so deep. Okay, so when we add many hidden layers, the learning will be deeper, isn't it? So for that reason, we are telling it is deep learning. Okay, so this can be used as supervised algorithm or even as unsupervised algorithm. So this is the representation of deep neural network. Okay, so here we are having input layer, various hidden layers, and output layer. So how to train it? So the training usually happens in deep architecture from the pixel. That is from the smaller units, the learning will happen. So this is the perceptron, and we learned about what is a dense layer. Okay, and we learned about what is convolution layer, what is a pooling layer, what is fully connected layer. Then we learned about what is activation map. Okay, what are all the various examples? Sigmoid, ReLU, TANX, etc. All the examples for activation map. Then this is the symbol CNN structure. Then what is a loss function we learned? Then we learned about optimization. Okay, optimization algorithm, what for it is used. So thank you. The remaining session will be handled by Kranti sir.
Good afternoon. So quickly going. So as we shared already, the Colab notebooks as well as the data sets. Quickly the data sets and what it consists of. So this data you already received and you have downloaded it. So after downloading, you might be extracting it. Once you extracted it, you have to upload it to your Google Colab again. Right. So once you upload the into the Google Drive, you will be seeing these things. One is Colab notebooks and another one is datasets. You have to see these two folders properly. After that only we can work on. Okay. Once you have these datasets, you will be finding only dogs and foods. This folder will not be there with whatever is shared to you. So don't worry about this folder. So these two folders, let us open that. This is a dataset, and I restricted the dataset. Actually, this dataset is a subset of Stanford dog breed classification datasets. So Stanford dataset is consisting of more than 12,000 images. We just restrict ourselves to make it quickly trainable in a Colab. So we reduced to only having 25 classes. In original dataset, it will be 120 classes. So 25 classes are there. This is one dataset, and we are going to classify any given image of a dog to one of the 25 classes. And the another dataset is fruits. Of course, this dataset is also trimmed for the purpose of easily training and fast training things. So here we are having only fresh banana and rotten banana. So we are going to classify whether the banana is good to eat or you have to throw it. So that is this dataset. So these are the two datasets we are going to use. So we're going to start with the Colab notebooks initially. So whenever you are starting classification, one thing you need to remember, it is unsupervised learning. So supervised learning means you will be having an input image, and for every image that you have, there should be a label attached to it. So each image will be having a label defining whether it is whether the image belonging to one of the class that you are going to classify. So if you are having a data set of 10 different classes, right, then you will be copying them, every class images, all the images belonging to one class, you are going to copy them into one folder, and you keep a class name for that folder. This is what you are going to do from the scratch. If you want to start classification using deep learning, this is what you are going to do. You open Google search, right? You open Google search, you try to find out one class. So dog, you'll get dog images. You'll be copying them, downloading them one by one. You'll be keeping it in one folder, right? And you keep the name of the folder as dog, right? And cat, you're going to cat, search in the Google search, whatever images you got, you download them one by one and you keep it in one separate folder, and that folder you'll be keeping a name as cat, right? So now you'll be having two folders, one is dog and one is cat. Inside all the images will be there. Now you can start from here. You are going to classification of dogs and cats, one folder. Under that you will be having dog folder containing 100 images of dogs, cat folder containing 100 images of cats, right? So this is the general starting data creation, right? This is what you do in the beginning stages. Now to make it simple and quickly doing, and to make the data set ready to be applied to the deep learning models, we do something else beyond this, right? So instead of doing only two folders, cat and dog, again go into the cat folder, again go into the dog folder, create two folders, training, validation, right? If you are not testing in any other images, you can create three folders: training, testing, and validation. Three folders. Now you have 100 images. How you are going to divide them? So in the dog folder, you will be having 100 images. You are going to divide them: 80 for training, 10 for testing, 10 for validation. Now three folders will be properly connected. Again, do the same for the cat folder. Inside the cat, you have 100 images. Divide them, create three new folders. After that, you will be starting. Right? This is the directory structure we generally prefer to when you are starting from scratch. Right? When you don't know anything, how you have to save the data set and make the data set ready to be applicable to the deep learning models. Right? So that is reading data. So reading data, we can read data in multiple ways. One is what we discussed just now. Right? Many other ways are also there, which is provided by the Tensorflow libraries, Keras libraries. They provide a different approach to read the data set, right? They themselves provide a lot of data sets freely available, right? So those things we are going to see in the beginning, because that is going to be the beginning stage. You need to have some data set to start with, and you have to save them in a proper order. Then only you will be able to access them and use them in the architecture. So there is multiple ways, and one way we are going to start is first collab file you have to open, reading data. I think this file is there with you. So you can open that read file, reading data file. So these are the libraries that we are going to use. TensorFlow, Keras preprocessing image, just image to array conversion. Label binarizer, we need to convert the labels to one-hot encoding. One-hot encoding, again, you will be in a doubt. What is one-hot encoding? Now, suppose you have two classes, only two classes, either dog or cat. Now, what you will do? Dog is 0, cat is 1. So, deep learning models or a computer will only understand zeros and ones, right? It is not able to understand cat and dog, right? So, it has to be in 0 or 1. So, dog and cat, two classes are there. You are going to keep it as 0 and 1. Now, if you have 10 classes, what you will keep? You will keep 0, 0, 1, 0, 1, 1. Likewise, you can keep, right? But to make it easy to differentiate between one class with respect to other class, we do one-hot encoding. So one-hot encoding means the first class will have 1 in the first index. After that, zeros in all other index, right? Following, first index will have 1 and remaining all 9 indices will be having 0. If I'm having 10 classes in the data set. So second class will have index 1, index 2 as 1 value, and the index 0 will be having 0 and remaining all 0, right? This is what is one-hot encoding. There is nothing rocket science in this. One hot encoding means what you are going to convert. If I am talking about class 1, so index 1 will be having 1, remaining all zeros. Class 5, index 5 will be having 1, remaining all zeros. Class 10, index 10 will be having 1, remaining all zeros. Right? So this is what is an one hot encoding. And we are using the data sets with multiple classes. We do use one hot encoding always. Right? So that is that for one hot encoding, this label binarizer will be useful. So Keras preprocessing image, again, image data generator. We'll be using this data generator later. SKLN model selection, train, test, split. So in the initial case, we said dog and cat, 2 folders are there. Inside 100 images are there. And I don't want to create multiple folders like test data, test folder, validation folder, and train folder. Then I can use this SKLN model selection, train, test, split. Automatically, one line of code will does the job for us. It will automatically divide the 100 images into training, testing, and validation sets. Okay. So NumPy arrays handling, glob is data set handling, directories handling, I can say. OS again directories handling. Right? So here image dimensions, I want to have a fixed dimensions for the image for all the images that we are using from the data set. So I want to convert all the images of multiple resolutions to a fixed resolution before sending it to deep learning. I'm going to use path, specific path, data, and p labels. 2 lists are created because we want to add those new image and add those new label somewhere, right? So 2 lists are created to handle that. So here JPEG files I am reading from that folder. I'm printing for the time being. I will to look at what is there. And this line is going to collect the label name for us. Now see this line what it does. So content drive my drive datasets dogs / dog breed, under that dog name dot jpg file will be there, right? So from that split 0, so dot jpg will go out, remaining path directory will be there. Are you able to follow this? Full path will be having this path, after that dog breed, after that dog name dot jpg, right? So dot jpg will go out. After that I have to extract the second value from backwards. Dog name remove, dog breed. So that is going to be my class, right? So that's why I kept it at -2. If you are saving without any dog breeds, then you can have here -1 only. Is that clear? So that is this line is doing. It is extracting me the class name automatically, this line. So I'm cross-checking whether it is extracting properly or not, right? So after that, read the image, resize the image, and change the color BGR format to RGB. Generally, OpenCV reads images in BGR format. Let us convert to normal format, RGB format. After that, image to array using the Tensorflow library, and data append, p labels append. So now each image, while it's reading, it is taking the image and saving it to the data at the same index, right? 0th index, right? Label, the same first image label is going to store in the labels at the index 0. Now next image will come, right? Read the image and push into the list, right? So next label, extract the label and push it into the labels list, right? Likewise, one by one image you are reading and keeping them into 2 lists, right? So these 2 lists will be having image, and image is of 8-bit format. So 8-bit format means all the intensity values will be 0 to 255. So normalization you have to do before sending it to any deep learning architecture. So for that purpose, I have given here. So here divided by 255. So 0 to 255 intensity values will be converted to 0 to 1 intensity, right? So after that, what is the size of the image, right? This full size, all the images with all the labels, right, all are kept inside the RAM for you. Now this basic way of reading data set is very hard to in practice. If your data set is consisting of 10,000 images and if your RAM is 4 GB or 8 GB, you won't be able to do it, right? But in the initial stages, this is going to work for you step by step. But this won't work if the data set is big, and deep learning architectures require data sets to be bigger, right? So I don't want to run this because it will take 2-3 minutes for running, because it has to read image by image and it has to store that in one list, label to one list, right? So this is how it is going to work. Once the image is read, it is normalized by dividing by 255, and the labels are extracted as breed names, right? It is not in 0 ones. We have to one-hot encode that, right? So for that purpose, these steps are written here. So initially, what is the breed name? It will show. After it applies that transform, that means labels as English names to one-hot encoded vectors, right? So first class will be having index 1 location as 1 and remaining all zeros. So that is what is happening here in these 3 lines. And here is the result. So first 2 images are belonging to the same class, and the same class is having 1 and remaining all classes are having zeros, right? So in the next thing, we are going to split the data. Now I didn't split the data as train, valid and validation and test. So I want to use the inbuilt function to do that step. So here data and the percent to one and 20% to the other, right? So this is a random state. This is a key that you have to mention to every time. Otherwise, every time you do this, run this code, every time it will be random picking of the images. If I keep this state same 42, every time I run this, the same set of random images will be picked up. Okay, this is going to be the key. If I change this, next time the random function will pick different set of images and keep in train directory. Is it clear? So that is how this train split will be giving us a split. You can change any value. 1, 2, 3. You can put 1 value. You can put 2 value. You can put, based on this key, you're going to have different set of random picking images kept in train, different set of random picking images kept in validation, right? If I change that key, this is going to change for the next time. That is why I want to fix it, because every time I want to run the algorithm, random picking only is happening, but still every time the same kind of random pick has to happen. That's why this. No, it's not number of images. It is only key. This is only key, which is going to change how the random pick has to happen. Okay. That means this 42 means it is picking only 42 images from the data set. It's wrong. It is not doing that. Okay. So here this value 0.2 is defining that. So 20% and 80%. 80% to the train and 20% is kept separate. Now, sometimes I want to divide the total set into 3 sets, like train, valid and test. Sometimes you want to have only train and validation, right? So this is going to be the difference. If I want to have train, validation and test, then I have to divide again the train set 80% part into 2, right? So that is why I kept again. This time 0.25. This makes me 2500 images as 1500, 500 and 500. So 1500 will be train images, 500 will be validation, 500 will be for testing. Right? After that, we'll do apply this whenever we got these things: train X, that is images; validation X, images; py is labels for the training set of images, validation labels for the validation set, test images and the test labels. Once we have train images, train labels; validation images, validation labels; test images, test labels, there you start off thinking, defining the model, right? This is how the data reading has to happen. Is it okay? Now your folder will be having only cat and dog, right? So that directory you are going to give to this set of cells, and it will prepare you the data set in proper order, having those 6 variables. When you have those 6 or 4 variables, you can start thinking of preparing a model or architecture, right? So this is one way, very lengthy way, and which doesn't work if your data set is bigger and you don't have sufficient RAM to handle it. Okay, So the next way, TensorFlow itself will provide many data sets for you in a binary format, which is a different way of storing the data sets. And it will take less amount of space if we store the data sets in binary formats. Okay, so in binary formats, we can import data sets from TensorFlow Keras. Default data sets are available, right? So you can, if you want to see where those data sets actually exist, you can see these data sets: Boston Housing, CIFAR 10, CIFAR 100, Fashion MNIST, IMDb, MNIST, Reuters. So these all data sets are available in a TensorFlow format, okay, binary format. So these all directly can be read. So here I am using CIFAR 10 load data. Is it clear? So directly I can use data sets, CIFAR 10 load data. That's all. By default, I will get all those 4 variables which I want. No need to do anything. Right? No need to create folders. Whatever data sets are available inside the TensorFlow, you just create in one line. No need to write all those cells. Done. Right? So after that, we need to normalize. We do normalize and use the model over it. Right? That is one way. Another one, again TensorFlow created data sets specific path, and that also I'll show you. More resources, models and data sets. Data sets. I think catalog. Here you can see lots of data sets are already available and in proper format defined by the TFDS. TFDS is again library belonging to the TensorFlow itself. Right? Now this TFDS is not limited to only 5 or 6 data sets like what we saw in the TensorFlow. Right? TFDS consists of many more libraries, many more data sets like AccentDB. We can go on before all graphs, images, right? Celeb data sets, cityscapes data sets, ultrasound, lost and found, scene parse, right? These are all image classification. We have again Caltech data sets, CIFAR 10, CIFAR 100, like with what we have seen just now. These all data sets are available in TFDS format. This is again different format. So that also reading is very easy. So we write in only 2 lines. We define what needs to be downloaded. Stand for dogs, right? Dog breed classification, right? So this data set will be downloaded and it will be stored DS train and DS test, right? So this class will be holding the training images as well as the labels in a specific format, which can be useful directly with the TensorFlow without doing anything. So train labels and train images are connected together inside this train DS train structure, right? So that can be easily used by the model directly. So that is another way. And the last way is TF Keras preprocessing image dataset from directory. We are not loading that anything in the RAM in the beginning, right? That is why we face problem with memory issues. So for that, again, TensorFlow is providing another alternate option is to read the image whenever it is required from the directory itself, right? It works as batches, right? We have to specify batches. If I specify as 32 batch size, at a time it is going to fetch 32 images with 32 labels and it will use it throughout the model, right? So that is how it goes. So reading the image from the path, validation split is specified 80-20 and given a label for that set as training. Seed again, this is a key. That's what we discussed in the above first method also. This is the random picking specific key. This you can give anywhere, right? So specific size, it has to crop automatically. Batch size, it has to select that many number of images at a time, right? So validation set, it can fetch 2500 files from the 2000 files prepared for training and 500 files prepared for validation. So this cell will be used for quickly reading the data from your directory. local path. So these are the 4 ways you can use, right? If this is clear, we can move ahead. This is the first step, preparing the data set and making it ready to be applied to the model, right? Once you have these 4 things or 6 things, whenever I say 4 things, that means I'm not taking the test direct, only training and validation. Training images, training labels, validation images, validation labels. If I'm considering test, then 6 variables will come into picture. So that is about reading data. You can straightforward run all those things by keeping those 2. Now, after downloading the data provided by me, so if you download it into the Google Drive front directory, then you will be able to run the code without any problems. The next one, these files are downloaded or taken directly from the TensorFlow tutorials, and I'm running these one by one cell now. So here in this file, what we are going to use is one fashion MNIST dataset. As we said, that is available already inside the TensorFlow itself. We are going to use that dataset, and in that dataset we will be having images, and each image is grayscale image, not a color image, grayscale image of specific size. What we are going to do is we are going to apply a neural network over it. Once we read the data, because it is TensorFlow format, it is very easy to read the data with one line. With one line reading, we have to convert that into 1 hot encoding if it is required for converting the labels into numbers, and divided by 255 whenever it is required for normalization. Once you're done, data set is ready. That means 4 variables or 6 variables are ready for. After that, what you have to do? You have to define a model, and that model is starting in the beginning stage. I want to have only a neural network model. That means in the initial or first layer, we'll have some neurons and one hidden layer of neurons, and at the end we will apply classification head, right? So only 3 layers neuron. That is what we are going to apply. So now if you want to run along with me, you can go ahead and start running the program from here onwards. TensorFlow, NumPy, Matplotlib, wherever it plots are required to plot. So first you have to connect it. So now it is connecting, initializing Google Colab. Once it is connected, you can see here, this will be open. Now I am not connecting anything to Drive, right? So I'm not interested to connect now Drive itself. So TensorFlow is loaded. Fashion MNIST dataset is shown here. It consists of 70,000 grayscale images of resolution 28 by 28 pixels, right? I'm going to flatten this image into one-dimensional array. That means 28 into 28. Number of pixels are there, right? If it is an image, 28 into 28 pixels are there. I am just flattening them. All the pixels are kept in one single row, right? So likewise, the first layer of my neural network should be having how many neurons? 28 into 28 neurons will be there, right? It has to accept all the pixels of one single image at a time, right? So that many number of neurons will be present in the first layer. Second layer, you gradually come down, because we are talking about how many classes? 10 classes. Okay, so 10 classes. At the end, you will be having 10 value. So it has to define which category it belongs to. Whichever category it belongs to, it has to give probability more there. And remaining all the classes, it has to give probability less. And in this case, right, one line for reading the data set. One line, fashion MNIST, and load data. That's all. So run this. It will take some time to download, and it's ready, right? So what are the classes that are present in fashion MNIST is t-shirts, the top, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, ankle boot. All these classes are there. So those class names are prepared here. So exploring the data, you can explore it quickly. Train images.shape, 60,000 images are there of size 28 by 28. Train labels, 60,000 labels are there. Trained labels will have integer values. Do remember, these are integer values. That means we have to apply 100 encoding for it. Test images 10,000. Test labels again 10,000. Let us plot those images. One image. So one image. I said whenever we read image, it will be of BGR format. That's why it is like this. Okay. So trained images divided by 255. Because it is a grayscale image, we need to normalize. Again showing, now this time .cm binary. These are grayscale images, no color. Here, this is a model. Now, anyhow, my data is ready. Is there anything done for? Okay. So binary labels are taken as it is. Hence 10 items sparse categorical from logits. Okay, so that's why they are not applying one hot encoding. I will explain what it means. So sequential, this layer flatten. What it takes is it takes an input image as it is, and it will convert those 28 by 28 pixels into a single one-dimensional array, and it will create those many number of neurons. Is it clear? So this first flatten layer will create that. Next one, dense layer, 128 neurons. All the weights are connected from 28 into 28 by 128. So that many number of weights are there. So 28 into 28 neurons in the first layer. Second layer is 128. So 28 into 28 into 128 weights will be there. So those are the parameters that is going to change while you are training or back propagating, right? So 128 and the next layer is 10. So in this layer, in between these two layers, how many neurons or how many weights will be there? 128 into 10. Right? Those many number of weights or parameters are going to update. So this is a model we are going to use, very simple model. So why we are doing this is this is a regression type of classification. We are not using image as it is. We are converting image into one-dimensional array. Then we are using a model which takes one-dimensional array as input. Right? But we have another set of neural networks, that is convolutional neural networks, which takes image as it is for the classification purpose. Right? So while defining the model, this is the model we defined. Right? So for this, many things are attached now. One is loss function to calculate the loss. Once you start predicting, you should be calculating the loss. According to the loss, you have to adjust the weights in back propagation. Optimizer, it has to adjust the weights with some parameter, right? That parameter will be controlled by this optimizer. How fast you are going to go into the smallest loss possibility. Metrics, how you are going to measure, whether you are measuring by accuracy or whether you are measuring by loss or whether you are measuring by F1 score, all these metrics will come. So these three things has to be provided for compiling the model. So model is given. Adam is the optimizer. We have many options in optimizer selection, as madam already said. Losses also we have many options available. And generally, if I am talking of one hot vector, then I should not be using sparse categorical cross entropy. We will be using categorical cross entropy. If I am converting the labels already into one hot encoding. Now here in this case, we are taking labels as integers, right? So that is why this sparse categorical and cross entropy and this from logic true. This form we have to use. If I am using one hot encoding, I'll show you later that we will be using categorical sparse categorical cross entropy and with a softmax layer in the last classification head. While doing the problem, while doing another application, there we will be seeing that. So model, compile. So then you are going to train. How many epochs you are going to train? 10. So there is no validation included here. Only train on the train images, train labels, it is going to train. If you are providing validation here, it will be doing the validation also. It will do first train and adjust the parameters and test on validation data, how it is performing. Based on that, it will try to improve the performance. If you are not giving validation data, it is only training and back propagating. 10 epochs, let's run this. Anybody wants to do it live, you can start running all the cells one by one, one by one. So only 10 loops. It reached 91%. Accuracy is roughly 91%. Now evaluating on the test, we divided the data into 80-20, and now on the test, okay, we had 60,000 in the train set and 10,000 in the test set. Now that test set we are evaluating. Now in the test set, it is giving 87, right? 91 and 87, very much good enough. If you have any overfitting, after overfitting, we will not discuss at this stage. Probability predictions, and you can continue on looking the results after the model is trained. You can continue on testing all these things. See here, he changed it to now softmax. Last layer included the softmax now. So predictions on the test images. So this is the probabilities given for all the 10 classes. We have taken one test image, 0th test image, whichever is it is predicting. So you can check here whichever is having the small, this value 9.6 into e power minus 1. This is going to have the bigger value compared to all other things. That means the class is going to be the 10th class, right? Argmax will give you the index of the maximum probability. Now you have predictions, right? So you take the model with a softmax layer in the last, and we predicted the probabilities by applying the evaluation, and we take first predicted output and check the probabilities, right? And these probabilities has to be converted to index. So the last index is 9, 0 to 9, right? So last index is 9. So test labels of 0 is 9. So that means predicted value is exactly same as the test value. Okay. So you can plot them. These are definitions to plot. Here the plots are come. So this is a correct prediction. This is a wrong prediction, and all the probabilities are shown as the bars. For each class, what is the probability? And showing number of total, so some few images at a time. Here you can see, because our accuracy is 87 and 90, so most of the things are correctly predicted. Only one is not predicted correctly. And these all are just again test image 1, printing the shape of the image 28 by 28. Expand dimensions, because image size is 28 by 28, but model will take as batches, right? If it is taking as batches, we have to create an extra axis with 0, right? So this part will create that expand dimensions of the image in the 0th index. That means whatever the index 28 by 28 is the image, right? Now it will shift those indices forward and create a new index and create it as 0. So 0, 28, 28 will be there. So that formatted array only the model will take. If it is a color image, you'll be having X, Y, and Z, right? RGB, right? So it will shift that RGB forward and create a new axis in the beginning. So we'll also call this as a channel last, channel first, right? Nowadays, if you are using TensorFlow, by default, channel is going to be the last one. Earlier, if you are using Keras, then there is a confusion. There is two options available. You have to select whether you are going for channel last or channel first. Okay, RGB. So third index will be defining the channels, right? X location, Y location, spatial coordinates, and the third one is RGB channels, right? So that is why channel last. TensorFlow by default is channel last. So this created one channel extra in the beginning and 28 by 28. Now this channel, this image can be for prediction. And probabilities came. So those probabilities, if you want to convert by using NumPy, argmax, it will give the index. And some plot. Okay. So that's all in this case. Here argmax is provided, which index 2. And in the figure, it is 0, 1, 2. Right? That's how it goes on. Now this is a regression based classification where we are flattening the image before using it. Now there is another possibility in deep learning is using convolutional neural networks also you can do the same classification. So that's going to be our second part. This program also you can run it in parallel if you want. So matplotlib for plots, numpy, arrays, OS, paths, pill again in another function which reads images. Pillow, actual full name is pillow. PAL again reading images and some basic processing you can do on images. TensorFlow, under TensorFlow keras, layers and the sequential. Sequential defines the model, how you are writing model. If you are writing layer by layer, layer by layer, layer by layer, and it is accepting that in a sequential manner, then you can write using sequential. And if you want to write as a functional, that means if you want to send some information from second layer to 10th layer, right? Then it cannot you cannot use the sequential part, right? In that case, you will be using functional model, right? We will see these functional models later. And this library is importing, and this file is using 3700 photos of flowers and a classification of flowers. And we have here 5 classes under the folder name flower photo, and all the classes daisy, dandelion, roses, flowers, tulips. Under that, number of images will be there, right? So this is the directory structure before starting. Now this time we are not using the normal way of reading data, or we are not using TFDS. We are not using TensorFlow directly loading the data set. We are going to use from the directory. We are going to download it. We store the data set in the same format, same directory structure, and then we are going to read the images from the directory itself. So this line downloads the data set for you. So let us see that. So this data set, whatever is downloaded, you cannot see here. It is stored in under root directory, right? So you have to find out that root directory. That is a little bit different task, which we don't want to learn now. So image count, what is that consists of? How many images are there? 3670 images are there of JPG format, and that is why here I specifically mentioned all the files having that JPG extension, extract them, right, and count them. 3670. So pill image open str roses 0, first rose directory, first image in the rose directory, read it. This is the first image in the rose directory. One of JPG format. So this is the next image of rose directory. That means we downloaded the data set and it is stored somewhere. We don't know yet exact path of that. Tulips. This is the image, and you can see the other image. Now you have to create the data set. Now we saw in the fourth way of reading the data set, right? In which we have to give batch size, we have to give image size, right? And then path, and then you have to specify whether how much you have to divide it to validation. Right? So all these things we have to mention. Batch size, height and width are given. Data set from directory, we are going to use that. So data directory we have to mention. Data directory is already mentioned somewhere. Let us see that. So data directory is mentioned here. Data directory is given, right? So under the data directory, the path is mentioned. You can see that path. What is path? You can just mention code here. So data underscore directory. You can see that where it is. So this is the path. Okay. So this is dot keras. These things you will not able to see it directly, but it will be there, right? So batch size, image width, and here we have mentioned validation split 0.2, data directory, training 123, image height, batch size. So it will read into the train data. Some other thing, remaining things will go into the validation data. And I want to show this specifically because also helps us. Many other possibilities are there in that one single function. I want to show that. API. So what we are looking at, tf.keras. What we have seen, utils. All the functions you can find out here. Their format, right? What are the input parameters you can provide to that function? All these things will be clearly given here. So utils, image dataset from directory. So you can open that. You can see the all other possibilities of input parameters, right? So we have given directory. Labels is another input parameter that you can control. Label mode, int, gray, int, one hot, all possibilities are there. Here, for the time being, I am reading all the labels as integer formats, right? I want one hot encoding. Then what I can do? Simple, one change here. So let us see this label mode. So, label mode. Wait a minute. We should be having a categorical variable by which we can provide. We can get by default one hot encoding. So here it is written. So categorical, if I change int to categorical, what happens is we'll be having encoded as categorical vector. That means one hot encoded, right? If I keep int as it is, then integer values. If I am having 10 classes, 0 to 9 values will be there. If I change int to categorical, then I will be having one hot encoded vectors, right? So do remember this. This is very useful function. So on this find ds, validation ds, path is not set. Okay, path is not set. Let us go. I am not mounting the drive. Let me see. Image height is not defined. I didn't run this. Now run this. Those are defined. So 3670 files are there total. In that 2936, that is 80% is kept in train. 734 are kept in validation, 20%. Class names, you can see. Visualization, all different set of images. Batch shape, now you can see because you are reading it using image dataset from directory, you have to give the batch size. So it will be reading the batches. Whatever you have given batch size, so 32 images at a time of size 180 by 180 by 3 is read at a time. So 32 labels are read at a time, right? So your data set, this validation DS is consisting of, our train DS consisting of at a time when model requested trained DS, what it is going to give to the model? 32 images and 32 labels, right? So all these things at a time it will come to the model. That is why these two are showing. And for improving the performance, not waiting for the next batch, right? So once it read one batch, the model will be training. In this meantime, you want the second batch to be ready, loaded to the RAM. You should not wait until the dataset is loaded to the RAM, right? So that time, if you want to reduce, you should be giving these 3 lines. Shuffle, frame cache, shuffle, prefetch the buffer size. Buffer you kept, prefetch the next batch and keep it ready for in the cache, right? So that it will be quick, right? On this, standardize the data as I said, 0 to 255 values will be there. So you have to convert it to 0 to 1. So layer start rescaling. One layer is created in the sequential model itself. We are not normalizing the data image outside the model. We are now normalizing the data inside the model itself. There is a difference, lot of difference. If you are processing this normalization outside, it will be happening in the normal RAM and CPU, right? It will take more amount of time, right? If you are taking that into the model, what happens is GPU will be processing that. Then super fast it will be happening, right? So all the things try to take inside the model so that GPU power will be helpful in doing the job for us. This is a rescaling layer I have created. Trained DS, batch size, one batch will go immediately. And perform this normalization layer over the batch, not by image wise. And after they normalized, again image and labels will come back, right? So this is how we'll perform the normalization quickly. Now this is happening inside the GPU. Okay, of course here I cannot mention what is GPU, what is CPU. Just that we can just check what is the RAM allocated, disk allocated, runtime, change runtime type. Here you can check what is allocated to you by the Google. So for the time being, GPU is allocated. You can request, check the TPU. Then again you have to run all the lines, all the cells. If you change the run type, you have to run all the cells, right? So this is the, now 0 to 255 is changed to 0.0 to 0.97. That means less than 1. Normalization happened. Now defining the layers of the model, right? So now I want to bring the normalization layer also into the model, as I said, right? So model sequential, here layers dot rescaling. In this first layer itself, I am doing the scaling operation. So that means 0 to 255 will go to 0 to 1. After that, I am starting the convolution layers. I think madam has shown how the convolution happens. What is the max pooling layer? Lot of layers are there. Don't worry, we'll see that layers here in the API. Tensorflow, we call it as API application. What do we call? Programming interface. Right? TF Keras. Here layers. Under this, you see lots of layers are present. Depending on the application, depending on the input, you will be using them. Right? So you can go through one by one. The instructions will be given. What is the function? What it does? What are the input parameters? What should be given as an input parameters? Right? All these things will be given. Let us check dropout. One dropout layer. So it is having rate, dropout rate, and the noise shape. If you want, you can provide it. So otherwise, what is rate? What should be given as a rate value? You can check it here. 0.2. Likewise, you have to provide rate value. So it will be ranging 0 to 1. Any value in between 0 to 1 you can provide as input parameter for the dropout layer. Right? So that's how each and every layer descriptions, their function, what is the format, what are the input parameters, what are the ranges of the input parameters, all these things can be studied here. So convolution layer is kept, and max pooling, convolution, max pooling, convolution, max pooling, and here I am doing the flatten. What does flatten do? 2 dimension to 1 dimension, right? Convolution layer, the output will be in 2 dimension only. Max pooling, generally reduce the size of the image by half. It depends. You can provide the value, how much you have to down, right? So again Khan, again Max, mostly you see these convolution layers will be having filters, number of filters, 16, 32, 64 is the number of filters, right? 3 defines the size of the filter, right? 3 by 3 is the filter size. So that is applied. So whenever you see whatever architecture you see, standard architectures, you will be finding out the number of filters will go on increasing layer by layer, and your image size is going to be reducing going depth, right? At the end you will do the flatten, and after that you will be having a dense layers which are simple neural networks, not a convolutional neural network. Simple neurons will be there, and at the end classification head will be there. So classification head means what you want, whether you want a one hot encoder, one hot values, that means probabilities, or you want a binary output 0 or 1, right? Or you want a real value, right? So based on this output requirement, the classification head will change. If it is a binary classification like cats versus dogs, you are going to give sigmoid there in the last layer. If you are doing one hot encoder defining the number of classes, you are going to use softmax. Softmax will provide you probabilities of all the 10 classes. Whichever is greater, that is going to be the predicted class, right? So that is the use last layer. Here we are providing only the number of classes directly. That means integer value will be coming as the output. That is why we are not doing one hot encoding anywhere in this, right? So if I run this, now the compile model, again we have many optimizers: Adam, Adagrad, Ada Delta, RMS prop, NADAM, SGD, right? All these possibilities, options are there. You can test them by using multiple things, right? Losses, again, because it is not one hot encoded, as I said, sparse categorical cross entropy from logits true, right? I'm not doing one hot encoding in this. I'll show you in the application where one hot encoding is used. So model summary, you can see what are the layers, what is the size of the images, right? What are the, how many number of parameters in each layer? That means how many weights and biases are there. These are going to be changing, adjusting themselves in backpropagation. Epochs, you can train it. I don't want to train it because of a limited time. We're going to quickly see the main application. So I'm going to stop here. Few other things that you need to remember. Now the pipeline, how it is going on. You have to read the data set first, right? So you have to properly convert the data set from the directories or from the folders or from TensorFlow or from TFTS. At the end, what I need, 4 variables or 6 variables, depending on the application. Once you have that, you have to create the model. You have to create the model. Always try to do the normalization and of course this data augmentation, everything inside the graphics card. Then only it will be quick. Otherwise, more amount of time you are spending outside, then model will be taking quickly, right? So try to implement normalization inside the layer. And in case of CNN, what are the different layer types that goes on inside? Convolution layer, max pooling layer, flatten layer at the end to convert 2D into 1D, and then dense layer, reducing the number of neurons, and then last the classification head. So this is the basic standard structure that you generally, in the beginning, you will be starting like this. Once you understand that from the second layer, if anything you need to send it to the 7th layer or 8th layer, the sequential manner code will not work. In that case, you have to use a functional. That means every line is a function. So if I write convolution of X, it will provide you Y, right? This X can be sent to anywhere. You understand? That is going to be the change. So data augmentation, I'm not going to work, because if you have a data set of very limited size, like 100 by 100 images for cats, 100 images for dogs are there, you want to apply some random image processing techniques to increase the size of the data set. right? So if I apply 30 degrees rotation to the docs class, I'll get another 100 images, right? If I do 60 degrees rotation of the docs, I'll get another 100 images. Increase the brightness, decrease the brightness, increase the contrast, decrease the contrast, go on. Some 10, if you minimum performing 10 different image processing techniques on it, you'll be having 1000 or more than images, right? So this is where image augmentation, data augmentation helps you to get a bigger data sets, right? And all the architectures, CNN architectures requires bigger amount of data. Then only they will perform well, right? So that's why data augmentation will help. This file provides you all types of data augmentations inside. You can go on. Anyhow, whatever we see, final one application in which we will be using all the types of augmentation techniques. Data augmentation is that learning rate schedules, right? So any optimizer, Adam optimizer we saw, any optimizer will have its learning rate parameter to control how quickly I want to change the weights, right? So in the back propagation, I understand this weight is wrong by this loss amount. Loss we calculated, right? So that loss amount, that weight is not correct. So whatever the correction has to happen, how fast it has to happen. So that is going to help by the learning rate. So whatever we are providing as an optimizer, we initially specify one learning rate parameter, right? So by that amount, it is going to decrease the weight or increase the weight. Okay, so that is not going to work throughout the training process. In the initial stage, you'll start with a little bit bigger value and slowly you generally reduce. Once the optimizer is reducing the loss continuously, at the end what happens is it will be jumping on from this side to that side and that side to this side, right? So that's going to happen. At that time, you're going to have loss as constant, accuracy is not improving, right? At that time, what we have to do is learning rate, reduce it so that it will take small steps towards the minimal loss, right? So again, decrease it. You have a lot of options for learning rate schedules. You can have a constant value for some 10 epochs. Next level, after 10 epochs, reduce the learning rate. After 10 epochs, reduce the learning rate, right? You can write this small code in a for loop and you can reduce the level. Or otherwise, there are fixed learning rate schedulers like exponential decay with respect to time, right? Initially try increasing the learning rate and suddenly start exponential decay, or try to be constant for some time, again after that exponential decay, right? All these things can be written. So that is, this file will provide all such kind of options, right? In this file, everything is given. How the learning rates program has to be written, right? Transfer learning. And most of the time we find that we don't want to write our model from scratch, right? So as I said, sequential models generally don't perform. If you go on writing sequential models, you have to use a resonate kind of models, or otherwise, if you're writing sequential models of 100 layers or 200 layers, what happens is the gradients that you are generating through the back propagation will not reach to the beginning from back. After 200 layer, the loss has to go back, right? So it has to go back calculating all the gradients. That gradients won't reach. So that is why sequential will not work if you are trying to write a bigger models. In that case, we definitely go to functional models. In case of functional models, we can have a jump, right? So that's where started these skip connections. So in the beginning, we used to have lineate architecture, that is the starting architecture with a sequential line of layers. Next, VGG, again sequential. VGG architecture is the second architecture. Of course, in between Alex architecture is there. Again, that is also sequential, right? So VGG, after that, up to VGG, people used to have 5x5 filters, 3x3 filters, and 7x7 filters like that. Later, Google observed that why not use all the 3 layers at the same stage, right? So why not use all the 3 sized filters in the same layer, right? What they did, image is splitted into 3 parts. One side 3x3 filter, second side 5x5 filter, next side 7x7 filter, right? So this is what the Google did. Once after that, Google tried to go on depth, increasing the depth, adding more and more number of layers. Width is anyhow started by adding 3 separate parallel paths 3x3 filter, 5x5 filter, and 7x7 filter. Okay. So ResNet identified that once you go on increasing the depth of the inception, it's not going to work, because again the problem of gradient passing to the initial layers is not going to work. So ResNet started the skip connections. So where even though the number of layers between the last layer and the front layer is more, the gradient is directly sent back to the skip connection, not going through all these layers, right? So by this way, they can increase the layers up to 1000 number of layers, right? So likewise, it went on. This, because of this skip connection identification, many more architectures came into picture, like DenseNet, SCNet, we have EfficientNet, MobileNet. All these kinds of things are happening after ResNet. Okay, those skip connections help to improve a lot for deep learning. Now we're going to the practical application. We have here two applications. One is fruit classification, because we provided two databases. Let us go with one, fruit classification. So you have to mount now, because dataset is now in drive. So you have to mount it. So first to connect, let it connect. So now drive is not connected. We can directly press this, or sometimes it will ask to run this code. So run this code. This code is automatically generated whenever you press this. No need to remember. Whenever you press this, if it is automatically connecting, it will connect. Otherwise, it will show this code. You have to run that. You have to open this link. Log in with the correct Gmail account. So here you can see the account, what account you are in, right? So that account you have to go and sign in. You'll copy this page, this sequence code. Enter this code. So this is for mounting, this is for unmounting. I don't want to do it now. Drive. Even if you are not going inside the drive, it's okay, but still I'm going inside. Some libraries which I'm going to use, and the drive is connected now. Remember, while running in your collapse, check these paths, whether these paths are right or wrong. So 224 by 224, I'm using here EfficientNet, which is the recent architecture, which will give good accuracy, right? So 224 by 224 size, 32 batch size, and the classes are 2. We have only 2 classes, fresh bananas and rotten bananas. So we are reading 20% split to the validation. I'm going to run this sequence, right? What else? Any tips I forgot as written in PDF? Data augmentation is covered. You have the file, you can check it, how to do it. Okay, here anyhow I will be using data augmentation. And transfer learning I applied. And what else I said? Transfer learning, data augmentation. Okay, one more thing I said that, so I will show you some online tools by using which you can do the classification process very easily, quickly. And you can even convert those models to your mobile Android apps also. Okay. So data is read. So you can see the batch size. I don't want to see now. I can show the images. These are the images. I'm not running it now. So auto tune, this is required to quickly access the data. And here I'm writing a sequential model, right? So I'm creating 2 architectures here. One is for the actual training process, and another sequential model to do the data augmentation things, right? Even the normalization things, right? So if you are reading through this data set, image data set from directory, it will give the values from 0 to 1 only. All the image intensity values will be lying in 0 to 1. That is why I am skipping this rescaling. Okay, so what I'm doing, random rotation. Randomly few images will be rotated. random translation, shifting here and there, random flip and random contrast. So all these things are applied. So our data set, if it is 100, now it will be nearly 400. Okay? So 500. So this I am creating as a sequential model because I want to run this inside the GPU, right? So the other model I am using here is transfer learning, right? So for the transfer learning, I will be closing this. What is transfer learning? So the efficient net or VGG net or maybe inception net, res net, all these architectures are run on a very big data set, image net, which is having millions of images with 1,000 classes, 1,000 different classes, right? That means it is more generalized already. So it is run on 1,000 categories with 1 million images. So it is already generalized, right? So all those features is already very much useful to differentiate many other things as well. Are you able to understand? So I don't want to run the model from scratch. I don't want to start weights as 0 and start changing the weights from there on. What I used to do is I download the model, efficient net model or VGG model. I will download the weights file. Whatever they trained on ImageNet, they share those weights files, right? So those weights files I will be adding. So those weights are already applied to the model, right? So what I will do in the transfer learning is I will remove the classification head, last line, right? Because that model is trained for 1,000 classes, right? I don't have 1,000 classes. I'm trying to classify only 2 classes. Only the last line is removed. Now, if I am removing the last line, what happens is, if I am not removing only the last line, because I want to have the convolution output. That means convolutional neural network outputs. So here we'll be writing include top is equal to false. That means not only the classification layer. Always the convolution, always the classification goes like convolution max pool, at the end flatten, dense, and the classification head, right? So this flatten layer, classification head, and the dense layer, all these things I need to remove. I want to have features. So features are up to the convolution layers or max pool layers, right? So if I remove the flatten, after the flatten layer I have to remove and use up to the convolution layer outputs. So those will be available as 2-dimensional feature set, right? So those features I will take from there, and I will create my own layers after that, right? Efficient net from beginning up to the last layer before flatten I will keep. After that I will create 2-3 layers of my own. That is what is transfer learning with the already existing model. I am not training. These all layers, whatever I kept from the existing efficient net, I am not going to change those weights. I am fixing those weights. I am not, even I train the model, those weights are not going to change, right? So that is what is this line is mentioning, false. So those weights will not be trained. After that, whatever I am writing the layers as global average pooling. This is similar to flatten. What it does is it takes average of all the feature set in 1 dimension and it will give only 1 value. So at the output of this global average pooling will be a 1-dimensional vector, right? So after that, batch normalization. Again, batch normalization is used to what we can say is used for increasing the regularization. Now you don't want to understand what is mean by regularization. So generally this will be used, this will be preferred in applications when you find that accuracy for training is more and accuracy for testing or validation is less, or you can say big gap is there. At that time you will be trying with this batch normalization and dropout layers. That will help improve in the regularization. Okay, so batch normalization is nothing but whatever you have features, once it passed through the convolution layer and non-linear, that is ReLU function, if it goes out, all the values needs to be normalized again. Like what we did in the initial image, 0 to 255 is converted to 0 to 1, right? The same thing is going to happen with the features in batch normalization. What it does is, whatever may be the values of the features in that particular image, what it does, it brings the values to -1 to 1. Okay, now you understand? That is what is batch normalization does. Dropout is using skipping some of the neurons while training in one batch, skipping some other set of neurons while training in the second batch, right? That is what is dropout. Number of classes, prediction. Now, this is the top part I created. This is the bottom part, all the efficient net layers. Over to that, I added some layers and then I created the model. Over that, compilation by providing proper optimizer. This is the learning rate which you can control by providing the schedules. Adam is used categorical cross entropy because this time I am using one hot vector encoding. And that one hot vector encoding you can see from here, I used categorical. And I'm going to run only for 2 loops. 2 loops also will take 10 minutes, right? So that's why I don't want to run it. Okay. So here you can see the plotting of the validation accuracies and losses are given. You can check that. I created the new folder which is not provided to you, right? So as in the beginning only I told you one folder I am not given. So that folder you can keep some other bananas which are written or maybe which are good into that folder, and you can use this same code and you can check the probabilities and you can check the label by using argmax. That is the file it is given. So this is about fruit classification. The same thing you will find out in dog breed. Closing. I'm not running. Again, mounting the drive. Same set of tools in the previous, all same. Here I'm using EfficientNet V3. EfficientNet comes in multiple, what you can say, multiple, not versions, madam, multiple sizes, you can say, depending on your resource. If you have a laptop, by default, your graphics will not be that much good. You will be limited to B0, EfficientNet B0 version. If you have a bigger system, if you can increase that to B1. That means what it does is, it will increase the size in this side wider. It will increase the number of layers in the depth side. EfficientNet B0 to B7 will go like, it will go increase the deep, increase wide, increase the image resolution. Okay, now you understand? So B0 will have smaller resolution image as input and smaller number of layers, right? So B7 will have more number of layers, more width, skip connections will be more, and image resolution is also high. So B0 starts with 224 by 224 image size. B7 ends at 600 by 600 size. And you can see the accuracy increases from B0 to B7, but you will not able to differentiate much in the higher side. So B6 to B7 is a very small increase, but B0 to B4, B5, you will see bigger increase in the accuracies. So same set of program here also I have written. So these are the images, different breeds of dogs, and we can classify same model, not changed. Of course, there B0 is used, here B3 is used. Here there is a 120 classes. We are not using 120 classes. We have to use 25 classes because in the data set that we have provided, it is only limited to 25. You also can try. You can also see these plots. These files are with you. Anytime you can try, run one by one. You can get it. So this will close this first thing, and I thought I will show you few online or offline tools which will help you quickly prepare the model and quickly use it in Android apps as well, right? So Teachable Machine is one. This is free. You can just register for it. Get started. Image project, audio project, post project. Image project, classification. Standard image model. Webcam, open, it will capture the images. If you have folders, upload folder. Define the class name, right? So second one, define the class name, upload your images, right? So likewise, after completing, train the model. You have very few options to control. The model also, you don't know what model they are using, but still you can run this epochs, batch size, and learning rate. You can control these parameters, and you will have the export model option. So once you export model, you have many options are available. You can either download as a Java file, you can download as a TensorFlow file. No need to write the code. This code will directly can be used to test the model, right? Now you no need to write the program for doing the training or back propagating. You understand? Everything is taken care inside. Only at the end you are going to apply on the test images for predictions. So that program is also given. So this program you can copy into the Colab and provide the images to it. It will give you the predictions, right? So this is option. Another option is TensorFlow Lite. There is a set of instructions to download the model with less accuracy I should not say, less resolution. Whatever the weights files will be there, weights files will come in float 32 format or int 32 format, that you can reduce the number of digits after 0, you can reduce it to smaller value, right? So that it will give you. So that is why it is called TensorFlow Lite. So the model size will drastically reduce. You are just removing the few digits after the dot, right? So you have TensorFlow Lite. These models will have less memory and this can be used in the mobiles. Okay, so the same thing I also implemented for mask wearing or not wearing in the mobile app. I can show you later. So this thing you can do, follow, to convert your created model without any writing code, without writing any code, right? So everything is done online and you have the model, download model, open Android Studio. Few techniques, few tricks are there. You keep there the model and your mobile will be having a new app doing the same thing. So whatever dogs we are classifying, whatever fruits you are classifying, do that, convert into the mobile app and use it. So that's how it has to be working. Is that clear? And another one similar to this is Lobe.ai. This also you can use. This is also similar kind of thing. But this you have to download, install in your system. There you have to do. This is also touch and play. So no need to write code. It will create you TensorFlow Lite models. You can download again, convert it to Android, and you can use the apps. This is one more tips I want to give. Now it is not, you should not say that I cannot do deep learning or I cannot do classification problems. Without knowing anything, any program, you can still do classification. Is it okay? So as you have the files, play with it. Today we are concentrating on classification part with some additional tips that improves the performance of classification. Next class we'll be talking about object detection using the TensorFlow again. After that the continuations will be segmentation. After that continuation we'll see what we can take as a text. On the text how deep learning will work. On the audio how deep learning will work. So many applications are there. It is not only limited to classification. Detection, segmentation on the text, on audio files, right? On 3D, generation of music, generation of what do you call artistic effects.
Text from image.
Text from image, image from text, video to text, text to video, image to text summarization. What else? All the things can be done using deep learning. Okay, you need to understand what is the input format, what is the output that you are expecting. Right? Inside everything is black box. If you know that, you will be genius. Okay, so I'll close this today here. Thanks for attending. We'll meet in next session on Friday.